Hey, so we're just going to continue where we left off from last video and finish with the PDE module. But this time we need to add a few more things. Let's go ahead and add we need to add the RCM value, R lower 125, R upper. I know that I talked about RCM in the second video or something like that, but in this video, I use two. The reason why is that you want one value for the temperature for when temperature goes beyond 43 degrees Celsius, the breaking temperature, and another one for when it's under that temperature. All right. So define three more parameters, and let's go ahead and add a not function variable. And I'm going to cheat a little bit by using my pre-existing COMSOL to copy those things. Make this video a little faster. R upper here, T break. Make this T, not T2. The reason why it's divided by 60 because we want in the units of minutes. Okay, and then copy this and go to my PDE and then general form. Minimum of those two. Right, and then make this 0 since there's no gradient. Check out the equations. So basically solving a simple first order differential equation here. This 0, 0, just solve for f, CM with the forcing function in there. Alright, one last thing, select the domains. Just one is the only one we're using, so unselect everything except for one. Alright, we only care about the bioheat stuff here. So in the study, let's see what we have here, and let's check this one. Okay, so I've noticed that that is using the PDE, so okay, good. So what I did there is to make sure that the first step does not solve for the time time dependent variables, which will generate an error if it's not in the right steps. And in step 2, that's where you want to use all of them. And then here is where the step 2 goes in. Okay. Alright, hopefully nothing goes wrong here, and we can test it here. Well, anytime now. We'll see if we have an error or not. Okay, it's running. Let's see how long that takes. It should be under a minute. Well, that's taking longer than I expected, but let's go ahead and finish this. We're going to add a 2D plot. We're going to add a surface. We're going to replace this with the PD. So this is the solve variable. Now we can plot the CEM values onto the surface plot. And you notice that this is a very high value. So what we're going to do is we're going to add a contour to this thing and do CM, and we're going to specify levels 30 minutes, 60, and 90. These are typical values we want to look at on the CM plot. And this is quite uh, quite bad because no refinement. Okay. Let's look at a log scale. The reason why it's like this because the power is 10 watts. It should look a lot nicer when you use a lower input power. Okay, so it works well with the log scale, but let's go ahead and lower our power input and have a better graph. Let's do 2 watts. And we're going to change our time to incremental step with 30. Okay, good. Let's do yeah, that's good. Maybe 1,000 seconds. Let's execute this thing. Okay. Maybe this time it'll be faster than last time. Okay, 27 seconds. So it depends on your computer or the current processes that your CPU is on right now. So for best results, close other stuff like Chrome. Okay, now you see that our contours are looking a lot better. Now we actually can use, let's see if that looks better. Extra fine. It doesn't really help with the resolution. Let's try recover, smoothing. Okay, whatever. So 90 minutes is right here. So let's see our temperature map. We don't have a temperature map here. Let's go ahead and add another 2D plot group and add 2D and replace with the temperature from the bioheat. Bioheat. Temperature in Kelvin Celsius. Plot it. And then let's go ahead and rename this to something we can easily recognize. Temperature 2D. And I'm going to add another contour plot. This is the CM with levels 30, 60, and 90. Okay, good. What I'm trying to show you guys is that when you click on here, right? Let's use a thermal light mapping for that. So you see the white line said for it's equivalent to having 90 minutes at 43 degrees Celsius, and the current temperature is 46 degrees, right? So 46 degrees. Well, this is a transient. This is current temperature at the current time. I mean, this integrate over time, and that's equivalent to having at this instant time of 90 minutes at 43 degrees Celsius if you've done at a constant temperature of 43. So we try and compare what's going on between CME and the transient response. I think it'll be more clear once we add the arenas model in there and compare it with the CEM directly. I hope this helped you guys get started with the CEM stuff. Sometimes it doesn't work, like you get errors. Make sure you go down here and make sure that it's not solving for the transient under the first dependent variables here. You only want to solve for the transient on the second part, okay? And another common mistake is not selecting the domain for it. Yeah, I made that mistake many times. So I'll save the last part of this tutorial for the next video where I actually add the arenas model in there. I hope you enjoy that. Alright, comment if you have any questions. I try to do my best to answer it. Alright, see you next video. Thanks. Make sure you're safe also.